Good morning, students. This video is going to explain about the secured socket layer of this network and cybersecurity module 1. Here we are going to discuss about the secured socket layer architecture, concepts, record protocol and record formats. Let's we start with this secured socket layer. One of the most widely used security services is the Secured Socket Layer SSL. And the follow-on internet standard, which is going to be known as TLS, as already I said about that, a transport layer security. So the later defined in RFC record format 5246. SSL is a general purpose service implemented as a set of protocol that are rely on TCP. At this level, there are two implementations choices for full genericity, SSL or TSL, which could be providing a part of underlying protocol suite and therefore be transparent to applications. Alternatively, the SSL can be embedded in specific packages. For example, most of the browsers come equipped with an SSL and most of the web servers have implemented the protocol. So this session which is going to be discussed about an SSL version 3. So let me discuss about this. This secure socket layer SSL, which is going to be implements 3 cryptographic assurances. One is going to be an authentication, and second one confidentiality, third one message integrity. Also which provides a secure key exchange between a browser and a server, and also which provides a security parameter negotiation, and it does not offer any repudiation. Let's be discuss about the SSL architecture. SSL is designed to make use of a TCP to provide a reliable end-to-end secure service. SSL is not a single protocol but rather 2 layers of protocol, as we have seen in this figure, which is going to be an TCP and upon that SSL record protocol. So it's a 2-layer protocol. So this SSL record protocol, which provides a basic security services to higher layer protocols, in particular which is going to provide an HTTP hypertext transfer protocol, which provides the transfer service for web client or web server interaction, which can operate on top of SSL. It's a 3 higher layer protocol are defined as a part of SSL. They are handshake protocol, chain cipher protocol and alert protocol, which are used in the management of SSL exchange. As we have seen in this figure, which consisting of SSL handshake protocol, SSL change cipher specific protocol and SSL alert protocol. Along with that, an HTTP is going to be there. So in general, if you're going to see about this, a particular the exchanges which is going to be done through 2 important SSL concepts. They are SSL session and SSL connection, which are defined in this particular diagram. So SSL connection, if you're going to see about the SSL connection, a connection is a transport. That's nothing but it's in the OSI layering model definition, and which the transport that provides a suitable type of service. For example, SSL, such connections are peer-to-peer relationships. So these connections are transient. Every connection is going to be associated with one session. As I said, the transport layer which provides a suitable type of a service, and for SSL, such connections are peer-to-peer relationships. These connections are transient and every connection is going to be associated with one session. Coming to the next one, SSL session. The SSL session is an association between a client and server. Sessions are created by an handshake protocol, and meanwhile the sessions are defined a set of cryptographic security parameters which can be shared among multiple connections. And meanwhile, the sessions are used to avoid the expensive negotiations of the security parameters for each connection. So between any pair of parties, for example, applications such as HTTP on client and server, there may be multiple secure connections. There may also be a multiple simultaneous sessions between the parties. But these features are not used in practice. But this connections, multiple secure connections may be possible. There are number of states associated with each one session. So let us discuss about the particular SSL concept. So the SSL connection, as we discussed about that, which is going to provide a peer-to-peer relationship and are transient and associated with one session, and the sessions are going to be created by the handshake protocol, and which is going to be defined by a set of cryptographic parameters, and which are going to be used to avoid the expensive negotiations. So let us discuss about an SSL sessions which is going to be defined over there. So there are a number of states associated with each session. Once a session is going to be established, there is a current operating state for both read and write, that is receive and send. So in addition, during the handshake protocol, any pending read and write states are going to be created. Upon the successful conclusion of the handshake protocol, the pending states become the current state. So as we have come across this particular diagram, which is going to be a session state defined by the following parameters. Let's discuss about one by one. A session identifier. A session identifier is nothing but an arbitrary byte sequence chosen by the server to identify an active or resemble session state. Second one, peer certificate. A peer certificate is nothing but an X509 version 3 certificate of the peer. This element of the state may be a null. Third one, comparison method. The algorithm which is going to be used to compress data prior to the encryptions are going to be described in this particular comparison method. Fourth state, cipher specific. What actually the cipher specific is? The cipher specific specifies the bulk data encryption algorithm such as a null or advanced encryption standard, etc., and a hash algorithm such as a message digest version 5 or secured hash algorithm version 1, which may be used for a MAC calculation, message authentication code calculation. It also defines the cryptographic attributes such as hash size, etc. The fifth state is going to be master secret. What actually the master secret is? Which is a 48-byte secret which have been shared between the client and the server for the authenticated transaction. The sixth state is nothing but is reassemble. So a flag indication whether the session can be used to intimate a new connections or not. Such things are going to be defined in this sixth state. Let me discuss about the connection, how the connection state is going to be defined by the parameter. A connection state is also defined with different states. Let's discuss about the connection state. The first one, server and client random. Server and client random, which explains about the byte sequences that are chosen by the server and client for each connection. Second one, server write MAC secret, which provides the secret key used in MAC operation on data sent by the server. Third one, client write MAC secret. The client write MAC secret, which is a secret key used in the MAC operations on data sent by the client. Fourth one, server write key. The server write key is nothing but a secret encryption key for data encrypted by the server and decrypted by the client. The fifth one, client write key. Client write key is nothing but a symmetric encryption key for data encrypted by the client and decrypted by the server. So server write key and client write key both are vice versa. And the sixth one, initialization vector. What actually the initialization vector is? When a block cipher in CBC mode is used, an initialization vector IV value is to be maintained for each key. So this field is the first initialized by the SSL handshake protocol. Thereafter, the final cipher text block from each record is preserved for the use of an IV initialization vector with the following record. The seventh state of this connection state is sequence number. This sequence number is nothing but, and each party maintains a separate sequence number for transmitted and received messages for each connection. When a party sends or receives a chain cipher specific message, the appropriate sequence number is said to be 0. Then the sequence number may not exceed 2 to the power of 64 minus 1. Such a way it's going to take care about the sequence number in the connection state. Next, move on to the